According to the Digest of Education Statistics, the total number of engineering degrees conferred in the United States has dropped by about 12% since the mid-1980s. And that's even though we know our population has been increasing. According to a study done by Kevin Rask of Wake Forest University that was submitted to a conference held by the Cornell Higher Education Research Institute last March, the full proceedings of which you can find at tinyurl.com/failingscience. Within that paper, he conducted a study of about 5,000 students that took a course in science. Of the roughly 700 students that started the physics series, roughly 15% made it all the way to the 4th class in the elementary physics series. There's clearly a problem with higher education in science and math in this country. Now, I know about physics. I tutored in physics, and I've majored in physics, and I'm going back for my master's in physics, and I know, just based on my observation, roughly 80% of the problems that students have with physics, or the first year students have with physics, is due to vectors. They don't understand how to use vectors. Now, vectors are a fundamental part of physics. You can't. Whereas most the mathematics you do in Algebra 2 at high school uses what's known as scalars. It's basically a quantity that only has one dimension of information, whereas a vector is a quantity that has multiple dimensions of information. And it's necessary to use a vector to represent physical data. You can't do it under any way else. And it's very complicated. It's something you have to get used to. It's something you have to be introduced to. Problem is, we send these kids into their first physics class, and they've never heard the word vector. They don't. And you physics professors expect these students to have complete command of vectors with basically a one-day introduction. It's ridiculous. And the math professors, now vectors is a math subject. It should be taught by the math professors. But they wait until Calculus 3 to teach vectors. So what kind of a game are you playing? You're waiting 2 semesters after they take their first physics class to actually give them a basic understanding of vectors. This is utterly ridiculous, and it needs to be solved. Now, that's for the physics professors. For the physics students, I have 3 tips on how to get through your physics classes. This is so engineering, math, or physics students have to take physics classes. The first tip is to read your book. You spend about, who knows, $200 some odd on these things, $300. You might as well open it up and read it. Most of the time in most of your other classes, or maybe in high school, you just open the book up to get the homework problems. Not so here. You need to actually read the information in the chapter. The best, and another, now what that'll do is you can read the unit before your lecture. What that will do is you'll now have, when you go to the lecture, it won't be the first time you hear it. It'll be reinforcing what you've already heard, what you've already read. And it also has a byproduct of preparing you for your engineering or science career. You may read this physics textbook and think, oh my god, this thing is freaking dense. I can't understand any of it. And it's true. Reading this kind of material is not like reading in your liberal arts or English classes where they assign you 50 pages. It might take you 1 hour just to get through 2 or 3 pages, but that's fine. Because you have to get used to reading this stuff. And in your, as an example, I just was assigned a project at work, and the manager gave me a whole pile of papers to read to prepare myself for the project, and here's the abstract for one of the papers. Axial and radial ion movement in the plasma of an ion laser. This paper presents a theory of ion movement in the plasma of a CW ion laser considering all ions in a cross-section of the discharge tube collectively. Results are given for an experimental study of the profile of the spontaneous emission of the argon-2 488 nanometer line under optimizing conditions up to the region of output power saturation. A comparison of calculated and empirical results with respect to line shape, line width, or temperature, and line shift. So, satisfactory agreement. Now, that's pretty dense. But you're going to have to practice learning how to read that stuff. And why not start right now by reading your elementary physics textbook? And you also get the byproduct of actually being able to have being able to hear the lecture twice instead of once. I firmly suggest read your textbook before the lecture. The other thing to do is to do your homework with other people. It is the kiss of death to take a physics course and to do your homework alone. And that goes for any upper division math or engineering course too. Don't do your homework alone. Find some people to work with. First day of school, get some phone numbers. Find some people that you can work with. Go to any of the physics or engineering clubs and just sit there. Find other people to work with. You don't want to work alone because this is very complicated stuff. It's your first time seeing it, and there's all kinds of nuances, and sometimes you just need to look at an equation a different way. And working with a group, everyone will be able to use their own perspective to figure out the problem. And sometimes you'll figure out a little insight here. Another person will find another thing that you missed. Someone else might notice that you accidentally turned a 2 into a 3, or turned a negative sign into a invisible positive sign, and that totally screwed up your answer. That's why you need to work with other people, because it's impossible to do this kind of work alone. So the kiss of death, working alone. And it also prepares you for your future career in engineering or science, because you're going to have to learn how to collaborate. And talking about science subjects is complex. It's not as simple as chatting about whatever you chat about. So seriously, work with others. The final thing is to make sure you focus on trying to learn concepts, not memorize quantities. The whole point of physics is how to think, how to analyze complex situations, or actually analyze any situation. And if you can just learn the basic concepts and understand how to derive more complex forms of these basic concepts upon each other, that's how you're going to get through the tests. That's how you're going to get through physics, by understanding the concepts and understanding how to apply it to different situations. So look for concepts, leave the rote memorization to the lower class, all the chemistry, biology, geology, and liberal arts majors.
Dr. Rando from the geology department, only man who's happy when they take his work for granted. But I'm kid the geologist, of course, but it's only because I have no respect for the field.
Are you trying to scare me? Because you're succeeding.
Well, then prepare to be terrified. If your friends are unconvincing, this year's donations might go to, say, the geology department.
Oh, dear, no, not the dirt people.
Or worse, it could go to the liberal arts.
No.
Millions of dollars being showered on poets, literary theorists, and students of gender studies.
the humanities.